Okay, this lesson is solving a compound linear inequality. We're going to graph the solution, and this is a little more advanced topic. So on these ones, because it says or, you want to make sure that it can be like it will include all the solutions regardless of where they are located. So for instance, we'll do a couple examples for you. So you solve the inequality like you normally would solve an inequality for the variable. In this case, it's v. So I'm going to add 3 to both sides here, and I get 2v is less than or equal to, whoa, I didn't mean to add 13. I just meant to add 3. So there we go. We get a negative 10. And then we divide by 2, so v is less than or equal to negative 5. And we have the or statement. We have negative 4v is greater than negative 12. We're going to divide by a negative 4, which means we need to flip the inequality. And we have v is less than 3. So because it's or, when we look at both of these, we have a, oh, whoops, I got to get my mouse. Less than 3. So we have open circle and 3, and it's all of this graphed. And then we have a less than or equal to negative 5. Notice that when we graph below like that, it is included in the less than 3. So we really don't need the dot right there. This will be our solution. So we'll just leave our solution. V is less than 3. It includes everything from both of those inequalities. And then we definitely are going to do a couple more examples. So we're solving for y here. We subtract 5 from both sides, and we get a negative 20. And we're going to divide by 4. So we have a y is greater than or equal to negative 4. Now we have an and. So we need to include solutions that they both cover together. So then we have 2y plus 2 is greater than 0. We're going to subtract 2. So 2y has to be greater than negative 2. We divide by 2, and we get a negative 1. So we have greater than or equal to negative 5. So we're going to go ahead and grab this solid dot, put negative 5, and we want greater than or equal to. That's this way. And then we want greater than negative 1. Okay, so we need to take out the part between negative 5 and negative 1. Because it is an and statement, we need to be able to find a number that is true for both of these inequalities. And the negative 4 will not work in the inequality y is greater than negative 1. So we're going to take out this part here, and that is our final answer. Okay, we're going to do one more here. So we're going to add 6 to both sides to get 0, divide by 2, w is less than 0. Here we're going to add 5 to a negative 25 to get a negative 20. Oh, wait, what's our word? Okay, we're looking for or. We divide by 4, w is greater than negative 5. So we have or. So if we're doing oops, I need my mouse. So less than 0, it's all of this here. If we want greater than negative 5, we have this. We need our dot. And it's all above here. So if the number negative 5 actually fits in my inequality, w is less than 0. And then 0 will work in the inequality w is greater than negative 5. So we just need to take out the dots, and it takes everything out. We actually want the entire number line because all of the numbers will work in either of those inequalities. And that's the end of the lesson.